Okay, groceries. Grocery stores receipts show that customers' purchases have a skewed distribution with a mean of 32 and a standard deviation of 20. So it says, explain why you cannot determine the probability that the next customer will spend at least $40. Okay, well, if we were to do that, we would use a z-score, right? So we would do z equals x minus mu over sigma. But the problem is that a z-score assumes that we have a normal model with a mean of mu and a standard deviation of sigma. Well, what do we know about this distribution? We know that it's skewed. Okay, so when we have a skewed distribution, then we cannot use z-scores, because z-scores apply to normally symmetric distributions. Okay. Then question B says, can you estimate the probability that the next customers will spend an average of at least $40? Okay, well, according to the central limit theorem, we know that even if a population distribution is skewed, then we know if the sample is large enough, then we know that the sample distribution will also come out to be normally distributed. Okay, even if the population distribution is skewed. So we know, we got skewed and we got a large enough sample, we know we're going to get a symmetric distribution with the same mean approximately, right? But the problem is how big? Well, usually around 40 is safe. So 40 is safe. So when our sample size is 10, that's not large enough in every instance. It might be large enough in some instances, but that's a fairly small sample. So we would not proceed because being conservative about it, we would want a larger sample. Okay. So then part C says, well, what if n is 50? Okay, well, if n is 50, that's good. Okay, so if we have a distribution and our original distribution has a mu of 32 and a sigma of 20, then our sample distribution will be normally distributed with a mean of 32 and a standard deviation of 20 divided by the square root of n. And what that'll wind up being is $2.83. Okay. So now we want to know what is the probability that the mean of that sample is at least $40. Okay. So what we got to do is we got to do a z-score, and we're going to do 40 minus 32 over $2.83. And if we do that, we're going to get 8 divided by 283, and that comes out to 2.827. So this would be a z-score of 0, and this is z equals 2.827, and the average is at least that, so we're going to shade to the right, and then we're going to go to the calculator, and we're going to say, okay, calculator, norm CDF, from 2.827 to 99, and that comes out to 0.002. So what is the probability? Well, it's highly unlikely. That's less than 1%. So the probability that the average of that sample is at least 40 is 0.2%. Okay.